The question you see above is about right angle triangles, but I'm going to try and solve it using complex numbers. In the question we have 3 right angle triangles where all sides are integers, and we're looking for the sides of the last triangle. What we do know is the smallest angle in each triangle adds up to 90 degrees. So how am I going to do this using complex numbers? If we represent the first triangle as this point on an Argand diagram with one side length 4 and the other side length 3, we can write it as 4 plus 3i. And do the same for the second one. And the third one we'll just leave as a generic a plus bi. Now a really interesting thing happens when we multiply complex numbers. As we've seen, each complex number can be shown on an Argand diagram where we get an angle associated with. Well, 3 complex numbers will equal another complex number, and it can be represented on an Argand diagram. But we already know what each of these angles add up to. They add up to 90 degrees. That on an Argand diagram is somewhere on this point. So I know all of these multiplied together will equal 0 plus something I. I'll use d because I'm going to use c later. I'll go ahead and multiply these first 2 terms for you and then multiply the next 2 terms together. But remember, we know this answer is equal to 0 plus something I. And remember, in complex numbers we can put the real parts with the real parts, the imaginary parts with the imaginary parts. So let me just write out the real parts. We're left with this expression in a and b. If I rearrange this, I get this expression for b. Now remember, we know a and b have to be integers. One thing I did leave out is there's actually infinite answers to this question. We'll go ahead and look for the smallest one. Now can you think what numbers we put in as a, so b is an integer? If a is 1, that'll be a fraction. A is 10, it'll still be a fraction. If a is equal to 56, b will now equal 33. And that's pretty much the answer to the question. We have 33, 56, and we just go ahead and use Pythagoras' theorem to find the length of this side, which is 65. If you'd like to see other ways to do this question, check out my full video below.